Welcome to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York University. You will now find us wherever podcasts are distributed. I am Mary Helen Armour, one of your hosts this evening, and I am joined by Paul Mackin. Tonight we are broadcasting live from the Allan I. Carswell Observatory on the Keele campus in Toronto, Ontario, Canada. York Universe broadcasts live every Monday at 9 p.m. local Toronto time, or currently 1 a.m. Tuesday Universal time. We also run in concert with our online public viewing, and we are probably going to at least have some live viewing tonight, as it seems like the conditions may allow us to get some decent images. So if you're watching the online public viewing for the first part of this, we will probably have some previously taken images. All the images you see are taken by the observatory. And later on, we will have live images. And during the YouTube, we will be simultaneously answering questions in the YouTube chat. Okay. So to follow our live show or learn more about us, please visit yorku.ca/science/observatory and follow the link to our online public viewing chat on YouTube. You will often see online public viewing referred to as OPV on our website and other social media sites. For any questions or comments about past shows or suggestions for future topics, you can certainly email us at observe@yorku.ca. You can also connect with us on Instagram at York Observatory, at YorkU Observatory. We have a pixel fed that is Allan I. Carswell Observatory, or on Facebook at Allan I. Carswell's Ops. Okay. Again, all of our programs are free. But if you would like to donate to help support the activities at the observatory, you can see our website at yorku.ca/science/observatory. And we will be monitoring the YouTube chat for questions and posting content there throughout the show. Hi, Paul. How are things where you are this evening?
Things are great. You're absolutely right. We might get some observing in. I've got basically a bit of a spring observing project, which we'll talk a little bit about later, or I guess it's a summer observing project now. And yeah, no, the skies are good. If I'm very lucky, when this conversation's over, I'll go outside and start the observing programming on my telescope. And when I wake up in the morning, there'll be lots of data to go through. So, how about you? How are things up where you are?
A little bit hazy, but probably okay. Uh, Once this is over, it might be dark enough for me to see some things outside. Maybe, maybe not. Certainly, though, early in the morning, the viewing is quite nice when it is clear out where I am, because I'm far enough north from Toronto that we have reasonably clear skies when the weather is good. So moving,
Yeah, for
yeah.
me, the skies are a little less cooperative, but technology can provide assistance in these matters. So.
Okay, so we'll move into our this sort of week in space or astronomy history, and I think you had a pretty major event to talk about.
Yeah, so major actually that a day has been dedicated in its honor. The Tunguska event, which is uh, Central Siberia. So this happened on June 30th, 1908. What's that? 118 years ago tomorrow. And basically, it was a massive explosion that occurred over a remote area of central Siberia. It's the largest known impact-related explosion in recorded history. Now, there have been others that are a bit before recorded history, including that which led to Meteor Crater in Arizona. But this flattened an enormous forest without no impact crater. And it became one of the most studied events in planetary science. The explosion occurred above ground rather than the surface, and that probably has a huge amount to do with um, why there isn't a crater, but there's a flattened area of trees, or there was. This is a very difficult place to get to. So it wasn't visited until the Russian Revolution happened, and then a few other things went on, like the First World War, and eventually they got out there, and the trees were still flattened. But most scientific evidence indicates that it was a small asteroid or possibly a comet fragment that entered Earth's atmosphere at a very high speed, broke apart under intense pressure, and released energy equivalent to several megatons of TNT, quite a few, several kilometers above the ground. Now, just to put this in perspective, kilotons are atomic bomb level, megatons are hydrogen bomb level. So it's a big explosion. The resultant shock wave flattened an estimated 80 million trees across, this is a big number, 2,000 square kilometers. But the remoteness of the region meant relatively few and maybe even no recorded human casualties. One of the event's defining features was the absence of a large impact crater, as I mentioned. Because the object disintegrated before hitting the surface, the energy was deposited in the atmosphere rather than, than going to excavate the ground. Later expeditions found extensive radial tree fall and burn patterns consistent with an airburst, along with some microscopic mineral particles that supported extraterrestrial origin, probably iridium, I'm thinking. But the Tunguska event transformed scientific understanding of near-Earth objects and atmosphere impacts. It demonstrated that relatively modest cosmic bodies can produce devastating regional damage without striking the ground directly. Modern planetary defense efforts use Tunguska as a benchmark for assessing hazards posed by incoming asteroids and for modeling airbursts over populated areas. Despite decades of research, some details, such as the object's exact composition and trajectory, really we don't know. We don't know that. The event inspired numerous scientific studies, expeditions, simulations, and popular accounts because it represents a rare, well-documented example of a powerful natural explosion caused by an object in space, but it just isn't documented well enough. Uh, and it occurred just before the advent of modern observational technology. Now, as I mentioned, this event actually inspired a day. So tomorrow, June 30th, is International Asteroid Day, and it occurs every June 30th, and it commemorates the 1908 Tunguska event in Siberia, which is the largest recorded asteroid impact in modern history. It's recognized by the United Nations. This day raises global awareness about near-Earth objects, space resources, and planetary defense. The awareness campaign was established in 2004 by a group that includes, and you got to love this, Queen guitarist Brian May, who is an astrophysicist, um, astronaut Rusty Swigert, who was the lunar module pilot on Apollo 9 and actually set up the B612 Foundation with Danica Remy, and a filmmaker called Greg Richards. The day's main goals include education and awareness, helping the public understand the risks and rewards of asteroids, planetary defense, showing modern technology and international cooperation to track and deflect near-Earth objects, and global events, sponsored expert talks, digital broadcasts, and public panels worldwide. And there is a lot of work going on in this area. Later this, there's several asteroid missions going on. We'll be talking about more of them today. But one of them of note, I think, is for October, when we go back to visit the asteroid impacted by the DART mission with the Hera mission, which is going to take images of the damage we did to that by flying the spacecraft into Didymos, I think is the name they gave to the moon. But all that being said, you've got a couple of other items on asteroids and in commemoration of this day.
Yeah, but even Tunguska was sort of such a famous incident because even at the time, it was observed from huge distances away. Like the light blast was seen, hundreds, if not thousands of kilometers away. And seismic stations sort of all over the Europe and Asia region, because even at that point, they were starting to measure earthquakes. Seismometers picked it up all over the place. So it was recorded at the time, even if people weren't quite sure what it was.
Well, it was, yeah.
Yeah, whether there were casualties or not is very hard to say because it's such an isolated area that if there were some kind of nomadic tribe in the area, they would have been wiped out and you never would have known about it. So whether they're casualties or not is totally unknown. And if you dig into it a little deeper, it was actually not until 1921 that someone actually managed to get out to the site to observe, to sort of see where the actual blast site was, just because, as you said earlier, the politics of the time, you're right, sort of in the throes of the Russian Revolution and then World War I. So it was quite some time before anybody got out there. And
the good news about that, it being Siberia, it's cold. And basically the cold environment preserved, at least, trees aren't growing rapidly there. You're quite far north, so at least they could see some of the damage. But yeah, it was a long time.
Yeah, I mean that's more than a decade later. So you've obviously lost a lot of possibilities. But in some ways, they were also very lucky with it hit, because if that had hit Earth a couple of hours earlier, if you look at the extent to which the trees were knocked down, if that had hit a little bit earlier, you could have wiped out Moscow or other sort of large chunks of geography in that area, and you would have been talking casualties in the hundreds, thousands, if not millions. So we got very, very lucky with what a remote area this one particularly hit. And I think that's part of what led to sort of the whole idea of the Space Watch when we sort of started looking at that, like, oh my God, like we really dodged a bullet with that one. And one of the other really interesting things has been a debate ever since. Like, they do think it's an air burst. It has a lot of, you can compare the characteristics to other explosive air bursts from other phenomenon. But there's been a great deal of debate of, was it possibly a comet, although that one seems less likely? Was it an asteroid? Was it an asteroid coming in at a low angle so that you had that air burst? Was it coming in sort of, how fast was it going? All this kind of stuff has been, the area of a great deal of study. And it's still a hard area to study because of physically where it is, and also because right now of the politics of that region. I am aware of some people who have tried over the last, 15 years or so to do some more modern geophysical surveys over the area. But given both the remoteness of the location and the politics of that region, it is still a very inaccessible site. So even though it's probably the most recent big one that we know of, there are other sites like Barringer Meteor Crater that we actually understand a lot better, just because they're so much more accessible and so much easier to study. I mean, even here in Canada, like we have impact craters within. There's at least one outside of Kingston. Of course, Sudbury is a massive impact crater. That's why you actually have such abundant nickel and platinum group elements in that area. So the craters are quite common. But the sad thing is most of these ones that are much older are probably much better studied for a whole variety of reasons. But as like I said, it would be nice if they could get some more detailed studies of them. But given how remote it is, and the difficulty of accessing, those parts of Russia, it's just limited our ability to study it as well as they would have liked to. But they do have eyewitness accounts. So they do have, like they were taken years after the fact. But some of the early expeditions did go and get eyewitness accounts of what had happened. Now, it's years after the fact. So who knows how much it's exaggerated or changed in people's memories. But it's just a fascinating event on so many levels.
It's interesting because my wife is from the bordering region between the Ural Mountains and Siberia. And if you go basically east of where she lived, there's nobody there. Like it's a very much an empty wasteland. Less so now because there's oil and gas exploration and whatnot going on. But yeah, it's a remote place, and good thing too, because as you said, Moscow, an hour earlier in Moscow would have been, toast, right? So
yeah. Yeah, so it's like I said, this is like you couldn't probably hit land on Earth and hit more of the middle of nowhere to some extent. Unless you were like in the Australian outback or maybe the high Arctic in Canada, you couldn't have picked a more remote place to hit, and the likelihood of fewer casualties for the extent of the destruction that happened.
yeah, absolutely.
There. So,
and again, good thing, right?
Yeah. Yeah, because even if that had happened over water, you would have generated a massive tsunami from the kind of forces involved. That's what people think. Oh, well, if it hits over water, it's no big deal. Actually, no, it's just as dangerous in some ways, if not more so, because the kind of tsunami you can generate with those forces would even dwarf the Indian Ocean one of, a couple of decades ago that was so devastating. So yeah, it's if you think about like, oh my God, we just used up all our cosmic luck. And the next time we might not be so lucky. So, but yeah,
Absolutely.
it's a fascinating. I guess from the point of view, like I study impact craters, so for me, this is just an absolutely like fascinating object, even if it happened over a century ago.
Yeah, and it's interesting. It's not a particular area of study for me, but and I know you're a geophysicist, so it would be for you, but sometimes just look at a map of Canada and, there are recognizable impact craters
Yeah.
here.
Oh, yeah.
Absolutely. And there's one of my favorite that I'd love to visit is on the Labrador Highway in Quebec. Unfortunately,
Kelly Staten, Miss
yeah,
Staten.
unfortunately, I drive an EV and they don't have chargers on that road yet. So
Yeah, I mean, but even close by to us here, you could go to Sudbury and you can stand in the one
yeah,
outlook, and you can actually still see some of the shatter cones up there.
yeah, yeah,
Um,
absolutely.
there is the Holliford impact crater, which is only about 40 kilometers sort of um, north and west of Kingston, which is there's not a lot to see. There's the Brent impact crater in the north end of the Algonquin Park. It's actually
Yep.
Brent Road that goes in there. That's quite interesting. I've done observations on both Brent and Holliford, so I know a little bit more about them. They're much smaller though, and very very old. That's one thing about most of the impact craters you're talking about, whether it's the Manitoulin or Clearwater or Mistatin or Cowie-Staten. I think they've changed the name a couple of times. They're all quite old, right? You're talking hundreds of millions of years for most of them because the Canadian Shield is so old. Um, but it's like I said, this one is much younger. Even Behringer Meteor Crater, they figure is less than 100,000 years old, which may sound old, but in geological terms, that's very new.
Yeah, but yeah, it's quite well preserved. I've actually been there twice,
Yeah,
three times, and it's but they go to great effort to keep it as pristine as possible now.
yeah.
Like you really
Well,
can't go into it.
yeah, the big advantage of Behringer Meteor Crown and the preservation is it's out in the middle of a desert. So there's very little rain, there's not much erosion, and there's no plant life.
Yeah,
It's kind of
absolutely.
it's a
Yeah,
geologist's dream, but anyways.
yeah. No, I absolutely hear you. So, but but if you want to look at craters, there's other places to go,
Oh
right?
yeah, Australia has a number of good ones. There's another place to see some. I don't think they have any really big ones, but they have a number of sort of moderate size ones. And one of the ones they have there, I think, has just been recognized as the oldest existing crater, where
Okay.
the impact is going back. Oh God, I saw the time on it. I could be wrong, but I think I thought something about 3 billion years old. But I might be wrong on that one, so don't take me on that. But it's been recognized as basically the oldest crater on Earth. So
Amazing.
yeah, quite a lot of them. And the thing is, like going on to some of the other little bits I had, looking at sort of other things, we've been observing things like the Tunguska impact for quite a while. In particular, we've actually seen quite a few hit the moon, right? So quite a few times we've observed asteroids hit the moon. Probably one of the earliest well-recorded ones was actually June 25th of 1178. So we're going back quite a while. And this is in the record of a medieval monk known as Gervais of Canterbury. It's very interesting, but the monastery has kept very good records of these kind of things, probably because they were up in the middle of the night saying prayers. So they'd observe these sort of things. So they noticed, the quote is, along with several others, they were looking at a young waxing crescent moon and see the upper horn split into a flaming torch, sprang up, spewed out fire, hot coals, and sparks. And the moon from horn to horn took on a blackish appearance. So this clearly seems to be an asteroid striking the moon. And modern observations suggest it's actually the 22-kilometer Giordano Bruno impact structure, that's just around the limb of the moon on its far side. So it's just sort of around the edge where we don't see. So they probably saw the results of the impact. They didn't see the impact itself. But Giordano Bruno seems to be a fairly young crater, and they're fairly confident that this observation from that time period was actually when this lunar crater was created. There have been some other possible links to this impact as well, with meteorites that have hit Earth in recent years. Um, More recently, of course, one of the big ways we pick up impacts on Earth, small ones and bigger ones, is through seismometers, because when they hit the ground, they actually trigger shaking. And they've had quite a number hit the moon. The InSight probe on Mars actually also um, recorded a number of impacts. What was really interesting in 1975, around this time, sort of late in June, the seismometers had sort of an extremely, relatively high level of impacts. So they had more large meteoroid strikes in a 5-day period that had been detected over the otherwise 5-day or 5 years of observations to that point. Um, and it seemed to have been quite a number of impacting boulders. Had these hit Earth, you probably would have gotten some pretty spectacular fireballs. And there may have been some fireballs on Earth related to it, but it would have been on Earth's day side, so it would have been undetected on the lunar surface. Right? So when it was happening on the moon, you had the seismometers recording it, but it would have been on Earth's day side, so it went otherwise undetected because we just couldn't see it. It is possible that event was actually associated with the Beta Tauride meteor shower that happens around this time of year, except they were striking the moon instead of striking Earth. Uh, and of course, probably the most recent smaller strike on Earth happened about 7 years ago around this time. You had an asteroid that came in. It was only about 4 meters, but it was spotted and tracked in real time, which was kind of cool when you get into this idea of tracking NIAs. So the Asteroid Terrestrial Impact Last Alert System, or ATLAS system, and the second Pan-STARRS telescope actually caught and tracked this in real time. And about 12 hours later, there was a radar station in San Juan, Puerto Rico, that recorded the asteroid burning up in the atmosphere over the ocean. So that was probably the first time we got a really good track of one as it came in and hit the atmosphere. But this was relatively small. There was only 4 meters. By comparison, when you were talking about Tunguska earlier, they figured that was probably an object more in the 50, maybe up to 100-meter range. So a fraction of the size of what created the Tunguska one. Tunguska might have even been bigger than that. It's very hard to say when you're looking at these things after the fact. But I think what all these things show is just we're always get hit, right? Whether it's meteor showers, whether it's larger chunks of rock, or whether it's something as big as what hit in and exploded under Tunguska, the Earth is basically always getting hit by these things. Okay? And frequently enough, they're going to be big enough to have, observable phenomenon. So, but it's like I said, it's it's asteroid day. There's lots of stuff to talk about.
Yeah, the chances of us getting hit by a large asteroid are 100% unless we do something about it.
Oh yeah,
And so one of the missions of Asteroid Day is to help us do things about it. And the DART mission is an example of that. And there are others. I mean,
yeah.
throwing one rock at another rock is one way to deal with it. Our rock being a heavy spacecraft, but there's many other ways to deal with it. Some quite exotic. If you find an asteroid early enough, basically paint it black.
Yeah.
Right? It would
Yeah.
change.
Yeah.
It would change
Change
the
the
amount of solar
trajectory.
energy it absorbs, and maybe alter its orbit, or put a very one of the B619 group. One of the models they came up with, so if you find one early enough, put a big spacecraft, and I mean a really big spacecraft, on the same orbit with it, and have its gravity just deflect
Oh
the
yeah.
asteroid just a little bit. So there's all sorts of ways.
Oh yeah.
And as we often say, dinosaurs didn't have a space program.
Yeah. Well, and it's interesting because if you remember, you're probably older to remember a few years back when there were a couple of these movies that were made about asteroid. uh, Deep
Yeah,
Impact, was that one of them? And there was another
Yeah,
one,
deep impact,
and there was
which wasn't a very good scientifically accurate
no,
film at all, but it was kind
no.
of fun adventure, you know.
But there was another one around that time too, because there were a couple of them that came out
Yeah,
around the same.
the other one I can't remember what it was called, but it had a pretty big cast. Robert Duvall was in it as among other people, but and Morgan Freeman was in it, but it was a little more accurate.
Yeah.
Not perfect, but a little more accurate.
Yeah. The other one had Bruce Willis in it, as if I remember correctly. And it was a little bit melodramatic in places.
Yeah, it was.
Eh, and the physicist in me went, yeah, well, maybe, but splitting it in half and having both halves go around the earth seems a little bit, yeah, that's
Hey,
a little bit
hey,
unlikely.
it's summer season. It's perfect drive-in fare, you know.
Oh yeah, exactly. Well, and there was, I think there was, they were well timed in a way because it was right when the technology was getting to the point that you could actually detect these things regularly, and you might actually have a chance of deflecting them. So I think it brought a lot of attention to the issue that otherwise it may not have gotten.
Yeah,
And I think it did to some extent prod, I think, some greater action on these kinds of things. So, you know,
yeah, yeah.
so sometimes the pop culture does actually have some benefits, even if it's a bit of a hokey movie.
We're more slaves to it than we acknowledge.
Oh yeah, oh yeah. So I still remember the other movie along those lines, getting a little off topic, but that volcano one off the coast of California, where the volcano suddenly pops up, and was it LA or San Francisco or something? I think they were like it was a trend for those kind of disaster movies for a while there. So, but asteroids got their say in it, and I think when NASA moved to more of these smaller, cheaper missions, and a lot of other countries followed suit, that's where you got things like Rosetta and oh, what's the one that went to Halley's Comet was probably a bit early for that, but Rosetta, a number of others where they went for smaller, more specific missions. Um, I think,
The faster, better, cheaper
yeah,
approach. Yeah,
yeah, smaller, more focused missions. I mean, Lucy is the one out there that just passed Donald Johnson in the last couple of weeks and is headed out to the Trojan asteroids. So
yeah, that's going to be
that's another
something
one.
else. Yeah, it's
Yeah,
going to visit, I think, in total 6 asteroids.
yeah. Well,
It's
it's had a couple
incredible.
of
So,
flybys of others in the same time, right?
yeah,
Kind of
so
like
it's already
extra
done
targets.
two. It's got yes,
Yeah,
and sorry, I misspoke. It's done two. It's got six more.
yeah,
So
yeah. Because they
and it
figured
goes
they
on
could.
for a long time. Like
Yeah,
it's finishing in the mid 2030s.
yeah. Well, that's the thing with these missions is what they've discovered is they can make them last a long time, right? Well, I have one for a little bit later that kind of demonstrates that.
Yeah.
But I'll hit our reminders. It looks like we've now hit about the midpoint of our show. You are listening to the York Universe, the Space and Astronomy podcast from York University. We are broadcasting live from the Allan Carswell Observatory at Keele campus in Toronto, Ontario, Canada. You can check out our website, yorku.ca/science/observatory to join our chat if you are joining us live. And if you have any questions or want to see some of our content, we have just moved over to live observing. I think they were going to move into we're on Venus with the
Yeah.
telescope to start with.
That looks like
I don't
Venus
know.
to me.
Yeah, and we'll go from there. Another couple of announcements. The observatory is having its big sort of end of summer fundraising that we call Astro Fair. Will be on the 29th of August this year. There'll be all kinds of fun events. We'll have the observatory open for tours. We'll have booths. We'll have activities. We'll have the Astronomy in Action Planetarium, which is a really great feature all by itself. We'll have walkthrough solar systems. We will hopefully have the new 8-meter sundial installed by then, and all kinds of other science-based activities and games. Ticket prices are $30. Might seem slightly steep, but this is our one big fundraiser for the year. So, please check out our website to find out more about it. I know some people expect atrium tours where we have our smaller telescopes up on the one parking garage where we have a fairly good view of the sky. Unfortunately, due to construction, we have had to put those on pause, probably until later in August, possibly into September. But we are still doing our observatories, and we are organizing instead what we call pop-up observing through the next month or two, which is where we just take some of our smaller portable telescopes to various locations around campus, and you can kind of come and talk to some of our wonderful astronomy volunteers and students who will tell you about what we can observe on the sky at that night. Again, all this information can be found on our webpage and on our social media. So I think that takes us more into the news. And you had something about, I think it was Euclid, to get off the topic of asteroids, at least briefly.
Yeah, so Euclid is an observatory by the European Space Agency. NASA's involved as well, and it took a picture of the bulge in the center of our galaxy, the Milky Way. Now, if you go outside on a dark night in the middle of summer, and you've got really good southern horizon to look at, and it's clear and dark, and there's no light pollution, you're going um, in that direction, and that is where it took a picture of. So the the Euclid mission has the most detailed wide field image ever obtained of the central bulge of our galaxy. It's resolving more than the numbers are amazing, 60 million individual stars. And it's not just producing a spectacular picture. I mean, that's great in its own right. And astronomers will tell you that pictures are basically their advertisements, right? But this image will become a reference map for future searches for exoplanets. And they're also going to be able to use a technique called gravitational microlensing to help discover additional exoplanets. So Euclid's mission was actually to study dark matter and energy. The telescope, in addition to its primary mission, is proving to be an extraordinary stellar survey instrument as well. That was kind of an add-on to this. Astronomers can now distinguish individual stars in one of the most crowded regions of the sky. And again, if listeners get a chance, they really should go and just try and be on the north side of a lake somewhere where it's dark, preferably pretty far away from Toronto, and look south, and you are going to see the region they took a picture of, just in the area of Sagittarius and Scorpio, and it's stunningly filled with stars. The data will help future missions, including our new favorite telescope, the Nancy Grace Roman Space Telescope, and it's looking for planets. And Nancy Grace Roman is very well suited for this because it's got a chronograph, which is an instrument specifically designed to help image planets. So I think you'd have to say that sometimes the most exciting discoveries come from a telescope doing something it wasn't primarily built to do. Certainly that happens, but we see a lot of that in astronomy and space science. Instruments repurposed. But this week's picture, it's pretty spectacular.
Yeah, it's like I said. I mean, if you look at sort of how telescopes are being better and better at sort of more and more detail. I mean, it's really unfortunate that a lot of people living in the city don't see the Milky Way. Up where I am, just north of Toronto, you can see it on clear nights. You don't see it down near the horizon. On the other hand, up at Killarney, which of course we have the link with for the astronomer in residence over the summer. If you are up there and you get a clear night, especially when there's no moon, you can see it quite spectacularly. I have gone up as astronomer in residence, and I've always had at least one really amazing night of observing where you can clearly see where the Milky Way is. It's, you know, like it's a, you can see it a bit in the winter, but yeah, summer is really the time to get a good look at it. And I certainly remember my grandparents had a cottage up in Quebec, and summers when we were up there, it was something you could see quite distinctly in the sky. And it's if you haven't seen it, it's sort of it's it's not a star. It's like, yeah, it's, I don't know. It's one of those really cool things to observe. So yeah, so it's definitely interesting to see sort of into the Milky Way and then the bulge of our galaxy. So can you, do you ever pick up images of the central bulge on your telescopes? Oh, I think I have lost my co-host momentarily. So I will move on to the next sort of topic then and hope he can rejoin. He seems to have had some internet connection problems, is what I am guessing. So the other asteroid related element I was going to cover is looking at the Hayabusa 2. This is Japan's sample mission. Oh, hi, Paul. You made it back. Are you back, Paul?
I am. I did. I suddenly heard everyone go away. I think it was on my end. I thought
Yeah.
initially it was on the other end, but I apologize.
Yeah. I was kind of talking a bit about the Milky Way, and then I saw you disappear. Your mic was having a little bit of breakup before that, so I don't know quite what was happening. But I had kind of
The
just,
internet in my neighborhood has been flaky for about a week now, so
yeah. You get funny things happening when you get a lot of heat and humidity into the various electrical systems.
that's true.
So I
That's
had
true.
just moved on to the Hayabusa 2 um, as sort of another asteroid related topic. So it is a sample return mission that first, I guess, studied Ryugu, if I'm pronouncing that correctly. I'm probably messing it up. I'm horrible with various pronunciations. I have trouble enough in English. Um, but it was launched in 2014. It had its primary mission, but it's still going and it's still in good shape. So in the next sort of week, it will fly by a small asteroid called Torafun. That's about July 5th or 6th. It's quite a small asteroid. It's one of the near Earth asteroids. And the really cool thing about it is because of the, oh, excuse me, the detailed or the high precision pointing systems and control systems, they are hoping to get within 1 kilometer of this thing. So that is very, very close in when you're talking in astronomical terms. Because this mission has completed its primary mission, what you'll now find is a lot of these people who are driving the spacecraft will get bolder and bolder in the risks they will take, because they figure the spacecraft, you know, is going to run out of lifespan eventually. So they will sort of push it farther and farther to see what the technology is capable of. So they're going to try and fly quite close to Torafun in the next sort of week or so. And after that, they have another potential target that I think is going to take a couple more years to reach. I don't remember the exact date, but it is also a fairly small object. And they are potentially even thinking about landing on that one, because it's like I said, as you get to the end of the mission, you know you're going to lose the spacecraft, so you can take more and more risks, figuring, you know, the reward is great and the loss is not that huge, considering you're coming to the end of the spacecraft's lifespan. So Hayabusa 2 is yet another asteroid related topic in this evening. So I think the last thing we wanted to touch, because we're getting into the time of year where people are more likely to be outdoors. It's cottage season. People go up north more. People just, are more likely to be outside in the warmer weather. We get more clear weather. Right? Um, so I thought we'd sort of touch a little bit on what the summer sky is going to be like for the summer. Now I know last year when I was up at Killarney Park, it was very disappointing because we had like no planets during sort of the observing times we had. As you probably saw earlier on the public viewing, though, Venus is out right now at the evening star. Right now it is intensely bright. I saw it last night. And it's setting a couple of hours after the sun, so it's very easy to spot. The really cool thing about Venus is if you look at it through like a really good pair of binoculars or a small telescope, you can actually see that it has phases because it's inside of Earth's orbit. When we observe it, it will go through phases somewhat similar to the moon, but you'll get like a crescent Venus and sometimes a full Venus and sometimes just sort of the half of the planet. So it's quite interesting to watch. Um, Jupiter's a tough one to see right now. It's setting very shortly after the sun, so it's really tough to find. So this summer, it's not going to be a great object. Saturn is rising. I think it's around 1 a.m. right now, if I have that right. But as the summer progresses, it'll be rising earlier and earlier. So by later into August and stuff, it'll be coming up as the skies are getting really dark, and it's another really bright object to see. Um, uh, Mars right now is rising fairly early in the morning, so you're only going to see it probably just before sunrise. But again, as the summer passes, it'll be rising earlier and earlier and becoming more visible during the night. So that's kind of where we stand with planets. So I think you were going to go on to some more exotic objects, things outside the
Yeah,
solar system.
yeah. As I mentioned earlier, I've had sort of an observing project going on since the spring, um, and I'm working through it. But uh, the spring is galaxy season, and we're sort of past that. I mean, with one exception, which I'll get to. There's a couple of exceptions, but I'll get to a main one in a second. But we're now moving into nebula season. So galaxies are large collections of stars outside of our own galaxy, outside of the Milky Way. Um, and then there's a thing called globular clusters, which are big balls of stars that are inside our galaxy. Uh, and also inside our galaxy are nebula, and they can basically be a couple of different types. And we're going to talk about, emission nebula, and we're going to talk about, planetary nebula and whatnot. But basically, they are clouds of gas and dust that don't necessarily generate their own light, but they won't, no, not, they will not generate their own light, but they could be transmitting light through them, either from stars forming in behind them or near them. And another possibility is they are the remnants of supernova or dead stars. So they make these shells of gas around a planet, and they are called planetary nebula because they sort of go around the star like a planet would. So a couple that I'm working on, and they're great to look at with even a modest telescope, or if you've got a smart telescope, give it these objects and it'll tell you where to find them. The Veil Nebula, it's actually a huge nebula, and I'm actually working on capturing it. But there's basically an eastern wing and a western wing of it, and you can capture them nicely. And it's a beautiful ribbon of gas and dust on both sides. And one of them, I think the western one, has an exotic name, the witch's broom, as well. And it looks a little bit like a broom. But it is a lovely sight. And again, easy to capture in a small telescope. Uh, not that great for binoculars, but we'll talk about others in a second that are. Um, So certainly worth looking at. If you look south again towards the bulge in the Milky Way, two nebula there that are just lovely, and these are nebula that are actually in star generating regions, although one of them, the Trifid, is a little more complicated. But these are the Lagoon and the Trifid nebulas, and they are basically large, very pretty clouds of dust. The Trifid may be the single most beautiful nebula you will ever see. It's just stunningly pretty. It's reds and blues and some green, and it looks like a flower. And it looks exactly like a flower, and it's just something to see. And again, you would see the two of those, and they're Messier 8 for the Lagoon and Messier 20 for the Trifid, down towards the southern horizon throughout the summer, basically. Um, as summer goes on, the constellation of Cygnus rises in the night sky, and Cygnus has a number of nebula in it. They've got the Cave Nebula, the Cocoon Nebula, the there's a couple of other names for them. I know them by their numbers, but they're generally similar to the Lagoon in coloration. The Tulip Nebula is another, very, very pretty. Several of them are viewable with binoculars, but smart telescopes will absolutely, or small telescopes will absolutely do them justice. Another really popular nebula in the summer, the Ring Nebula in Lyra. And if you've had any interest in astronomy in your life, you've seen this object. It is like a smoke ring around the remnants of a star. The star exploded in a supernova, and it pushed out this beautiful multicolored smoke ring. Absolutely worth seeing. It's quite a small object, but it's quite bright. And Lyra, the constellation it's in, is well positioned in the middle of summer, right overhead almost, to take a look at this. The other nice thing about that is it's very close to one of the nicest globular clusters you can find in certainly in the northern part of North America, which is M13, the Hercules cluster, which is this big, quite impressive ball of stars, sphere of stars, not terribly far away from the Ring Nebula in Lyra. And this is not a nebula, uh, but it gets honorable mention. It's a holdover from Galaxy Season. Is the Andromeda Galaxy, which is our sister galaxy. It's approximately 2 million light years away and getting closer every second because we are very likely going to collide with it in a very long time. So don't worry, it's not happening next week. But it is massive. So try to imagine the full moon. It is three times bigger than that in the night sky. Now, it is visible technically to the naked eye. You need pretty dark skies to see it. But a pair of binoculars or a wide angle telescope, this becomes an incredibly beautiful object. But it is really big. I'm photographing it now, and I'm having to do it in four separate images. I'm putting it together in what's called a mosaic. Um, and it is just it's everyone's image of what a galaxy should look like. Beautiful spiral arms, and it's got two companion galaxies going around it, just as we have companion galaxies going around our own Milky Way. So those are a couple of objects certainly worth looking, and lots of information online about them. But absolutely, summer's a great time for being outdoors in the country, and even just have a pair of binoculars with you. You'd be amazed what you'll see. I think we may have lost Mary Helen. So I guess I will
All
take
right,
her
no,
last time.
sorry, that's me. My sorry, my mic just my mic
Okay.
just got there's a cat playing with things on the floor. Um yeah, but I was just
Okay.
saying that both the Ring Nebula and the Andromeda are definitely targets we've had up at Killarney, that we've looked at up there because they're quite spectacular to the average
Yeah,
viewer.
they are. They
What
are.
does disappoint people when they look at the Ring Nebula, because it is a planetary nebula. I mean, you always see like the lovely Hubble images where you have like the reds and all the look the different colors in the ring, and when you look at it through the telescope, it's just green. That's
Yeah,
people don't realize
it's
is that the color you see sometimes on those Hubble images has been adjusted for various reasons. Um, but they look quite different through like a visible eye telescope.
yeah, and if you look at our OPV feed right now, there's a great image on the right, M57, the Ring Nebula, and that's taken, I think, with our 1 meter telescope. That gives a pretty good feel for it. That's I mean that's a telescope in the middle of Toronto, so you don't have the best skies, but the 1 meter is a remarkable instrument, so that gives you a good feel for it. But that's visible in a very small telescope. It really is
Yeah,
worth seeing.
yeah. So one last object, if you're talking about summer observing, and I'm sure it will come up and later um, York universes this summer closer to the date, is of course the Perseids. They hit their maximum about August 12th and 13th, and they are probably one of the best sort of shows of the summer. They peak the 12th to 13th, and you can get dozens of shooting stars, little sort of the meteor streaks across the sky during the peak. You even get the odd fireball. I know every year where I've been up there at Killarney, we'd see at least a couple of fireballs because I was usually up there pretty close to that time of year. But even for like more than a week on either side of the maximum, you can go out, and if there are clear skies, you're looking sort of roughly a bit north, but you will see uh, shooting stars pretty regularly when the skies are clear. It's probably the most consistent meteor shower. I would say the Leonids at the right time in the cycle are one of the most spectacular ones, but the Perseids are pretty regular year after year after year. They're a pretty consistent shower, and they always sort of that mid-August period. Um, so they're always a great one to look for because you can see them even from sort of later in July, uh, starting to sort of appear. I know I was up at Killarney like about the last week of July last summer, and we still saw a number when I was doing the public viewing the one night. So they are a great summer target.
And it's interesting. They're a great summer target, absolutely. But there's another interesting thing about that part of the sky. We talked about the Andromeda galaxy. It's not terribly far from Perseus in that part of the sky. There's also a great double cluster, the Perseus double cluster. So, uh, if you get a look in that area of the sky with a pair of binoculars or just lying back in your lawn chair, you are in for a treat.
Oh yeah, it's at that time of August, I think is probably one of the best months for just plain observing of things you can find in the sky, right? Um, Partly because the weather's usually good too. But
But
it's always
also the
probably been
days,
one of my
yeah, and the days are starting to get a bit shorter again, so you get more
yeah,
night.
you're not yeah, you get more nights. You're not quite so stuck. Um, so yeah, but I think that's bringing us pretty close to the end. But I think this summer sky thing is kind of fun because it gives people an idea of what to look for over the summer. Now the planets change every year. Sometimes you get more, sometimes you get less. But the nebula and the Perseids are always going to be there summer after summer. So if you're listening to this podcast at a later date, planets are always changing, but the nebula and the Perseids are a summer staple that you get year after year. So So I guess we're getting pretty close to wrap up time for our podcast this evening. I want to say thank you for joining us again tonight. You have been listening to York Universe, the astronomy and astrophysics podcast written and presented by the students, faculty, alumni, and friends of York Universe. Your hosts this evening have been Paul Mackin and myself, Mary Helen Armour. This podcast and past episodes are available wherever podcasts are distributed. You can also always connect with us on Instagram at York U Observatory. We are on PixelFed at Allan I. Carswell Observatory, or on Facebook at Allan I. Carsweb Ops. Our website is yorku.ca/science/observatory, and we have lots of interesting content. We, have a huge number of podcasts up going back quite some time. And as always, we are a nonprofit organization, so we do appreciate any donations that you make to help us continue to sort of fully operate the observatory, which can also be found on our webpage. So thanks for tuning in this evening. Thank you, Paul, for joining me tonight. I know you were a kind of a last minute replacement on this show. So I greatly appreciate having someone willing to step in as co-host at the last minute. So we wish you clear skies and good evening.
Good evening. Have a nice night.